We're going to start our unit on powers, exponents, and roots. Today we're going to be connecting the visual to the written math. We're going to be looking at both the geometric model and the written powers. Before we begin, we're going to look at what our calculator will show us. If I need to find the square of a number, I'm going to be using the number here, this button, x squared. If I'm trying to find the root or the square root of a number, it'll be this button here. Now in this unit, we're also going to be looking at cube roots. So y to the power of x will let you choose your base and your exponent. If you are looking for the cube root, you'll use this little button here by hitting second function, and that will allow you to choose whichever root you like, and in this case it'll be cube root. Let's begin at what actually x squared means. A perfect square can be written as a power. N squared is the same thing as n times n. And we can see that that is a two-dimensional picture. We have the side times the side, which is then the side squared. This will look a couple of different ways in questions. First, questions will ask you to find the square, or a question might ask you to find the area, or it might simply be written in mathematical form of x to the power of 2. These directions all mean the same thing. This picture, where they're showing you a square with side length of x, is the same thing as x squared, which is the same thing as 7 times 7, and then the result is 49. Each of these items all mean the same thing. Going in the other direction, when they ask us to find the root or the square root, it means the same thing as if they give us the area and ask us to find the side length, or they ask us to find the root of x. These directions all mean the same thing. It would look like this. They give you the square, tell you the area, and ask you to find the side length. Or they ask you to find the root of 49, which is the same thing as the root of 7 times 7, and the answer is simply 7. Now let's look at the cube. A perfect cube can be written as the power of n to the power of 3, which means the same thing as n times n times n. So the same number has been multiplied 3 times, hence the little 3. Okay. Another thing to remember is because of this little 3, we're also looking at something in 3 dimensions. So what do the questions look on this kind? Find the cube, find the volume, or x to the power of 3. These directions all mean the same thing. If they give you the 5 beside the cube, they want you to take 5 cubed, which is 5 times 5 times 5, which is 125. Let's go in the other direction. What if they ask you to find the cube root? That's the same thing as giving you the volume and asking you to find the side length, or the cube root of x. This little 3 means they want the cube root, not the square root. These directions all mean the same thing. Visually, they might give you the volume of 125 and ask you to find the side length. Or they might ask you to find the cube root of 125, which is the same thing as the cube of 5 times 5 times 5. Those are the factors. And our answer is 5. In chart form, we can look at our perfect squares in a couple of different ways. If they give us 8 squared, we can expand that. It means 8 times 8. And we can solve and find the standard form of 64. A diagram or a model for 8 squared would be a picture of an 8 with 8 as the side length and 64 in the center, representing area. In our next example, if they give us 4 times 4 to begin with, we can go in either direction. We can write the 4 times 4 as 4 squared. We have 2 4s being multiplied. Or we could solve and get our number 16. And we can do our model or our diagram, where we have a square with 4 as our side length and 16 as our area. Lastly, if they give us 25 as the standard, and we're expected to work our way backwards, you have 2 choices. If you know your math facts well enough that you know that 25 is 5 times 5, then you can go ahead and enter it. If you do not, you're going to need to use your square root button on your calculator. Once you've used your square root button and it tells you 5, then you can note the expanded form would be 5 times 5, and the power would be 5 squared. Don't forget your little diagram. Let's switch and look at cubes. If they start by giving you the power, you can work forward by expanding that into 4 times 4 times 4. I can solve that using my calculator if I need to figure out that the standard of 4 cubed is 64, or the answer, and then our diagram. A little cube with a side length of 4, and I would write the 64 in the center to represent volume. If they started us with 6 times 6 times 6, I could simply solve it. Using a calculator, type in 6 times 6 times 6 and get 216. Going in the other direction to find the power, 6 would be my base, and it's to the power of 3 because I have 1, 2, 3 of those 6's. Written 6 to the power of 3. And then our diagram. A cube with 6 as a side length. In our last question, 125 is the standard. Again, if I'm really good at math and I know that 5 times 5 times 5 is equivalent to 125, then this is not a difficult question. But when we get into standards that I don't know the factors for, I'm going to use my cube root button. So the cube root of 125 is 5. I need to write it 3 times because I rooted it cubically. 1, 2, 3 for cube. I'm also going to write down the power, 5 to the power of 3, and finish with the drawing. 5 on the side length beside the cube, and if I could write it in with teeny tiny letters, it would be 125 in the middle representing volume. Your homework, which is due next class on page lesson 2.1, page 52, questions 1 through 6, 9 through 12, and 14.